It's actually always great to come down here in Southern California. I lived 4.5 years, or 5 years almost, in Laguna Beach. I know Orange County is different and San Diego is different than LA. I learned that. I originally came from Germany, and it's quite a different experience, but I really enjoyed it. And 2.5 years ago, I moved up to the Silicon Valley in San Mateo. That's where we're located. We have now also an office in Bellevue. And what I'm going to talk today, we heard a lot about scalability. I would like to add an additional dimension to scalability, and it's all around data. We have built a database. That's really what we have done, a distributed database, to be very clear. And I will talk about why we have done this. I mean, I'm not a CTO, I'm a PM, I'm a product manager, I love what I do, but I started now multiple times products with 0 customer. We have now roughly around 800 customers by end of the year. I think we will have 1,000. And we are thinking about how we can evolve Snowflake to a system that can support tens of thousands of customers, because we see the data challenges in the world and with existing systems, and that's what I will talk about and show you then some real world example, one of our public use case and another one just using us as an example how we deal with the challenge of scaling data, because we are collecting massive amounts of data. We're using internally Snowflake, as you can imagine, but it's much more to that, and I will show you some of the numbers, some of the data that will hopefully illustrate the scale that we're operating on. I thought it would be good to kind of look back into the history of data systems, database systems, just to set the context why we are looking into a new system. So I just put in here some of the vendor names. I hope it doesn't come across that the intention is to bash here any of these vendors, but rather to focus on their approach. So I think in the past there were just 2 approaches, the shared nothing and the shared everything approach if it comes to large scale analytics and data warehousing. The shared nothing approach is really about you're distributing the data across different compute nodes, and every of the compute nodes can process parts of the problem. It's a fully parallelized system. That's kind of what Teradata pioneered in the 80s, and Oracle kind of went the other way with the shared everything approach. You can make arguments for each of those approaches, but I think if you look at specifically the next generation of shared nothing solutions that came out, the Netezas, the Verticas, the Greenplums, at the end of the day, I think it was proven that shared nothing was the architecture that was the right one if you wanted to deal with large amount of data, at least on-premise. And then 2009, 2010, I think the vendors came around, Cloudera, Hawthorneworks, who wanted to commercialize Hadoop. And we'll talk about that in a second. And then really, I think, disruptive to the market was what we call the first generation of cloud data warehouses. Examples are in AWS Redshift and in Azure, the product that I worked before I joined Snowflake, Azure SQL DW. And then I think there's a new wave, at least that's our view. You might argue with us, as a second wave of cloud data warehouse solutions, and we believe Snowflake belongs to that. And I will come back to that picture once I went through all the challenges that we see with our customers and maybe reevaluate. Just a quick check, how many of you are working with database systems? Okay, that's the majority. Have anyone worked with Hadoop? Okay, all right, good, thanks, that helps. So I would like to spend a little bit of time on sharing my journey as I worked on these different products. I started really with Parallel Data Warehouse. When I was a young grad student, I worked on Hadoop. I couldn't believe when I came to the US to see the hype around Cloudera and Hawthorneworks. And then I was a founding member of Azure SQL DW before I came to Snowflake. But the challenges that I want to highlight and illustrate are common across all of those products that I have seen. And so hopefully that will resonate with you and we can have an interactive kind of conversation around that. So the first challenge is really around scaling data accessibility, and that kind of translates into supporting concurrent workloads. I think what we hear over and over again is as your business grows, you have the need to support more workloads, more users hitting the system, and in the center it's always data. You want to analyze data, you want to be adaptable, you want to change as you learn more about the data. And so you have lots of users who potentially want to access the data. And the existing systems, at least that's what we believe, are not really solving this challenge. Because if we go to customers, they say, we have to load before we can actually access the data. We have a period of time where the system is completely locked down. We load the data in, new data is there, and then people can access the data. That is kind of a typical pattern with existing systems. Then you have the requirement that you would like for certain workloads want to reserve more compute power, more processing power than for other workloads. For example, if you want to have a massive load, you would like to reserve a lot of compute power for that load, but for your maybe data science workload where you run a Python script against the data, you might not want to use hundreds of servers. So you want to have the flexibility on choosing the right size for your data processing task. And on top of all that, if you have concurrency in your system, you want to have some form of synchronization. Well, in the database world, this translates into transaction management. And you don't want to be in the business, at least that's what we believe, in synchronizing all these concurrent access. You want to have a system that takes care of it and make sure that you are isolation level recommitted, as the database community says, which means basically you don't see any dirty reads as you load and access the data at the same time. So that is one of the challenges that we see, how you can build a system or how you can use a system that allows really everyone in your organization to ask questions and run queries against. The other challenge I think is well known. The Hadoop world really started with that claim to say, well, existing systems do not really scale when it comes to new data formats. Again, so if you look at the Teradatas, at the Netezas, or what have you, those systems were optimized for structured text files at the end. But now if you think about new applications, maybe you're working on those in the cloud, there are new data formats like JSON, who became very popular, and you want to have systems that can enable processing of JSON data very efficiently. Right? And so you have much more data now, and typically what happened, I mean, in some cases, not in many cases, but in some cases, people thought about, okay, we need a different system than a relational database system, and brought in Hadoop and kind of separated the data sets. What happened was that now you have data silos, because it's hard to bring data together, or you have to build code that kind of accesses these different systems, and then you deal with a bunch of challenges there. It becomes very hard to share data across your different groups, even within an organization. Scaling operations. If you think specifically about the first cloud data warehouse generation, as we call them, typically those systems were on-premise systems that were basically shifted to the cloud. They were based on, Azure SQL DW is a great example, was based on SQL Server. SQL Server was built for the on-premise world. Shifting it into the cloud will definitely help in terms of removing the data center, and you're not in the business of dealing with hardware anymore or networking. But it will not solve the problem of tuning the system. You still have these gazillion system knobs, and I worked at SQL Server. So I was really confronted with many of those customers who came, I use now this cluster key, and I want to improve it. What can I do? I use this system knob, and I want to bring on a new workload, but it doesn't work. And so you are in this constant exercise of tuning the system. You have to think about distribution keys. You have to think about sorting keys. How is your data laid out? Those challenges are not going away with a product that's being just shifted from the on-premise into the cloud. And that is really an issue that we are seeing across the board. Or if you want to scale, we talk all day long about scaling. The cloud really is all about, with a click of a mouse, you can scale your operation. That doesn't work for those database systems. It's incredible to just see that if you want to get another server, more processing power, you have actually system downtime. And why? Well, it comes back to the shared nothing architecture that was founded 80 years ago by the Teradata folks. Or it was actually Stonebreak, but Teradata took it and made a product out of it. Because the data is attached to compute. So if you put another node in, and you want to enable a load balanced execution, you would need to redistribute the data because that new node is empty, it doesn't have any data. So scaling translates into downtime because you need to redistribute the data. And now imagine you are scaling your business and you have petabytes of data, let's say even terabytes of data. That will require a long, long time. Scaling total cost of ownership, it's maybe very trivial to put that slide out. But again, in the context of databases, it's fascinating to see how many systems are violating the core principle of the cloud, where you can't just shut down compute. And again, it comes back to the architecture of a shared nothing approach, because storage and compute are tightly coupled with each other. So you can't just go and shut down the compute and not pay for what you're not using. And obviously in the on-premise world, if you think about scaling your business with the data volumes that you're then dealing with, it's just not feasible anymore. I just don't see 5-10 years from now that anyone will use Netezza or Vertica. It's great products, specifically those two, great database systems. But why the hell would you spend that much money and with all the hassle on-premise? So it's just doesn't scale in that sense. The last challenge I want to highlight is sometimes a challenge that I forgot in the past, because I was so much focused on database and how we can further optimize the query optimizer and what have you, add additional features. It's really how the database can fit into the overall ecosystem in your organization, and security is an important aspect. I cannot count how many times now, being at Snowflake, people ask me, what about federated authentication and single sign-on? I have my identity provider, AD or Okta these days, and I don't want to keep my passwords in the database. How can you enable us to use these identity providers in a very easy way? So federated authentication, but all the whole story around key management end-to-end encryption. It starts with that, end-to-end encryption, and then who owns the key, and how often is the key rotated? Do you have a key hierarchy? All these are important questions that come up if you think about building a secure data system or building a secure solution, period. So what we have done is we have introduced a new architecture. We have built a brand new database. We are not built on top of MySQL or Hadoop, God forbid, or Oracle or Redshift or any of those systems. We have built a brand new system by leveraging the core cloud building blocks, EC2 and S3. And this is basically a new database that we have built. And we have written up a paper at the Sigma conference, database conference. You can go and dive deep into that. Really, in a nutshell, we evaluated both the two approaches that I was highlighting in the beginning and kind of combined them in a sense that we have now a centralized storage, which is S3, that scales automatically, so you're not running into the bottleneck anymore with the shared everything approach where you have a centralized storage that won't scale. But we eliminated the challenge that I was highlighting a lot around coupling storage and compute with each other, but rather separating compute from storage. Now, everyone is claiming we are separating compute from storage. Even the Hadoop world is claiming that in the world that we are separating compute from storage. What is really important is this third layer, and I won't go to every aspect of this layer, but the third layer, which is what we call the cloud services layer, which allows you to basically build the transaction manager, for example. I was talking about synchronization and dealing with concurrent workloads, avoiding dirty reads. While you load data, you want to access data, but you don't want to read dirty values in the sense that you want to see either the committed transaction or the values of the committed transaction or the previous state. That is not a simple, it's not a simple task to solve. It's very difficult to build such a transaction manager. Many systems, including the Hadoops, are not supporting transaction today. The other parts are security. I was just alluding to it. End-to-end encryption, things like IP whitelisting that you can use, key rotation. All these things you want to have out of the box, and you should not write code to accomplish that task. All this magic is happening in our multi-tenant cloud service layer, written in Java. Our execution layer is written in C++. And then we have the storage, which is S3. The execution layer is relying on a concept which we call virtual warehouses. Virtual warehouses might be a misleading term. It basically read compute clusters. You can create a compute cluster of one single node, we call it extra small, and you can scale up to 3XL, 4XL, over hundreds of servers you can reserve. And you can call this virtual warehouse Artin, you can call it virtual warehouse Bill. Bill is doing the loading, Artin is doing the querying. You have other virtual warehouses who do other workloads, other data processing tasks, and they're completely separate from each other. And you can scale them up and down, you can even pause if you don't want to use them. That is kind of the architecture that powers, I think, the new type of database systems that we believe are the ones who will be the ones people will use in the cloud, I think. And it comes back to the architecture. It's really as simple as it is, that existing approaches, shared nothing or shared everything, will just not work in the cloud. So a real use case, now I can talk all day long about Snowflake, but I thought it would be good to bring up Localytics. Localytics is a public use case, so I can use them here. And Localytics is scaling with us, or we are scaling with Localytics, I actually don't know. Localytics is a company on the East Coast who is offering an analytical service to their customers that is powered by Snowflake. So first observation is that now the data warehouse is not something anymore that sits somewhere in the corner 5 IT guys are operating on, but is rather exposed to hundreds of users. And what Localytics is offering is a service for their clients. Their clients are developers who are building mobile applications and would like to understand how their users are interacting with the mobile application. And so Localytics is offering a service to collect all this information about how users interacting with these mobile apps, and they can then look into dashboards and better understand how customers are using it so they can improve their marketing and what have you. And so Localytics had the challenge to use before Vertica, and it didn't scale. Their business took off, they had more data, and they wanted to basically support more customers who hit their system to analyze the data, and wouldn't scale. So with Snowflake, they have now a production database that has 4 trillion rows, so that corresponds to roughly 3 petabyte of data raw. This is before compression. We have roughly a compression ratio from 5x to 10x depending on the data. We have this concept of micro-partitions. I can dive into that in the Q&A session, but that's one of the core principles of how we are using S3. We are basically partitioning the data in small micro-partitions. It's a more fancy name for basically columnar compressed files. And why is it so important that we are chunking up in smaller files? Well, you can then do what is known as partition pruning, eliminating files that are not needed to answer a question. And no other database system can do this because they are not built on S3. Really, that's what it is. There's a little bit more to it, but you see just the pure number, 25 million partitions for a database. That gives you then the performance. And what they have built is different workloads accessing the same data within one Snowflake deployment. So you have a virtual warehouse of medium size that is loading this raw data 4 terabytes per day. with a certain SLA they need to accomplish. They have a dashboard. That dashboard is what I was alluding to, that they basically expose to their clients as a kind of the analytical service, so they can dive into the data and understand, to see the graphs and what have you. Then they have another internal reporting tool for themselves and for their sales guys, so they can understand their own data as well and see how the business is doing. And then they have an ETL maintenance virtual warehouse for that. So these are all workloads that are running against the same data, and the data is, I mean, it's a couple of hundred terabytes after compression. What they also did is, I was talking about the challenge of data sharing and data silos. So they have their clients now asking them, can you please give us access to the raw data? Because your dashboards are great, but we want to actually do more sophisticated analysis because we have the domain knowledge. So they have a company in Berlin, actually, where I'm from, who is doing a personalized newsletter app, and they want to have access. They have a fitness app, as customer fitness app, we all know, and they want to do more sophisticated analysis on their raw data. And what they have done now is they're using what we call instant data sharing. Because we are built on S3, you can now instantly share data with your clients without moving data. So these clients, the fitness app and the personalized newsletter app, they are also now on Snowflake. And via role-based access, they can, and secure views, these are concepts in the database we support, they can open up certain portions of the data and share that instantly. It's basically sharing an S3, a portion of the S3 bucket with these clients without any data movement. Back in the days, I mean, still a lot of people do it. How do you share data? You export data out in files, and then you ship it some ways, and then you import it back. You run in all type of issues, whether it's data types. We don't even talk about security here. How secure is this? With this method, you have instant data sharing, and the data is in the right format, and you don't have to actually do any complex ETL. So let's review where we started. Well, you might not be surprised if you hear a Snowflake person saying those systems do not scale. But I hope I gave you some ideas about why those systems, we believe, will not scale as your business scales. It doesn't mean that Snowflake will be the solution for every challenge. No. And if you deal with small data sets, go ahead. You can use MySQL for that matter, right? But if scalability with data is of concern for you, I think you should evaluate the architecture of those approaches and see if you need a different one. Just to share a little bit data, we are doing analytics in-house. What we are using is a product called Snowflake, obviously, but we're also using a BI tool called Looker and a very modern data integration tool called Fivetran to move data from our SaaS sources, whether it's Salesforce, Marketo, or even Jira, into Snowflake. And then we have the production data, which we call customer service data. This is data about the data, metadata about the usage that is very important for me as a PM to understand how people are using it into Snowflake. So we have the challenge of how do we scale? Because we are really tracking every transaction that is happening with the system. And here, just to give you an idea about the scale, we hit recently 1 billion jobs that we are successfully executing. 1 billion jobs here translates into everything with respect to interacting with Snowflake, whether it's select statements, DML statements, show statements, metadata operations, and what have you. Just amazing to see that you are operating now millions of jobs every single day across the 4 regions we are in on the globe. The other number that I want to share is kind of the total storage number. Is just incredible to see. At Microsoft, I certainly didn't have exposure to a petabyte of data. And this is post-compression, by the way. So you can, again, take your favorite number, 5 or 10, and then multiply. And see, basically, we are in a petabyte range. The other interesting piece is, and that is always the most fascinating part for me as a PM, if I interact with data, I wanted to understand what we can do with a particular feature. So copy feature basically is our way to load data into Snowflake. And what I was running, and I started with, okay, let me see who is using actually this feature. And I was running into this one customer, cannot talk about this customer, but it's from a gaming industry. And they have this requirement to load very quickly data from their operational systems into the analytical system because they want to really understand in real time how those gaming folks are interacting with the games and want to, I don't know, do marketing and upsell things. It's fascinating. I'm not a gamer, so it's always interesting to see and hear about these use cases. I was running into this incredible number. I was even looking back then, it was around 70,000 loads per day. I thought, oh gosh, what are they doing? First I said, I'm surprised that we are supporting this type of scale. That was a different conversation. But I went and had a conversation with this customer and asked them, what are you trying to do? And discovered that they are not doing it the right way, or they agreed that they're not doing the right way in terms of how they load data, because we didn't have a feature that allows continuous loading patterns to support them in a good way. And as a result, I got basically new insights about how we can further improve this, our product to support these very attractive use cases. And this is just a story that I want to share with you, how I personally benefit by being able to look at the data and have a good conversation with one of our customers and move the product forward. So that's all what I wanted to share with you. Obviously, I hope you have a lot of questions that I can now help answer.